Hi everyone, welcome back to our channel. Today I will explain one important topic in Kubernetes which is persistent volumes. By using NFS volumes we can create persistent volumes to our application. I have created a blog on this with a practical example by using our Spring Boot application with MySQL DB. So let me explain the complete concept here. This is the blog where I have explained everything in my hash node. So before jumping into this concept, I will explain what are the other volumes are there in Kubernetes, like temporary storage, empty directory volume is there, host path volume is there, and when coming to the persistent storage, this PVC, NFS and other cloud providers volumes like AWS, EBS, Google Cloud storages, and all these things are there, and other configuration management like config map and secrets. Non-sensitive information we are going to use the config map, and sensitive information we will use the secrets. And finally we have dynamic storage. Without creating the persistent volumes and persistent volume claims before, we'll dynamically create a persistent volume based on our persistent claim. So using storage classes, these are the different volume types in Kubernetes. Now we'll discuss on NFS storage type. So this network file system volume concept is very important. It is persistent type volumes in the Kubernetes. And one basic thing about let me discuss about emptyDir. Here I have explained about emptyDir, right? This one is the non-persistent one. When we stopped or deleted our pod, application pod, or our SQL DB pod, the data automatically will be deleted. So and coming to the host path, this host path also based on our cluster node directories we will use this host path, and but the actual real use case of this host path is to get the privileges to access the Docker or containerd privileges to run container runtime tasks. So for that purpose we will use the host path, and accessing some host logs or Docker socket we will use this host path. So when we are going back to NFS, these NFS volumes will allow multiple pods running on different nodes to share storage via network mounted file system. That means we'll create one NFS server on any AWS EC2 server, other or on-premises storage server. So first of all we need to set up a NFS server, and we'll integrate with we'll mount that NFS server on our Kubernetes cluster nodes, so using some commands. So once we have mounted this NFS shares with our cluster nodes, then we can create persistent volume and persistent volume claim to use that NFS server volumes for our applications. So this is the flow. So let me explain briefly. Here I have created a NFS server using AWS T2 micro EC2 instance for testing purpose, and we need to open the ports 2049 and 111 all in the TCP, custom TCP mode, or UDP is optional, you can use or not necessary. So here I have created a shell script to install NFS server, so to automate the process without doing manual. So by using this shell script we can able to create NFS server. It will create NFS server, and all the necessary steps it will do, like creating directories for NFS exports. Here we are going to create MySQL and PetClinic directories for our project purpose. And this is the step. We need to create a SQL user, and we'll add that as SQL user to a group. And further, we are going to set the permissions and ownership for the directories what we have created, so to get access of for our from our cluster. Okay. Coming to the configure NFS exports, we are going to add these necessary permissions in the exports file /etc/exports file. So by doing all these things, our NFS server will be ready. Then coming to the next part, we have to integrate this NFS shares with our Kubernetes node. For that purpose, we need to install NFS common package on each node, and we need to mount directories. All these things we need to do to integrate NFS share with our cluster nodes. For that purpose also I have created a shell script. By using this, we can able to achieve within the short time. So here we need to replace our NFS server IP. So then automatically it will do the necessary things what we required for NFS shares. So these are the NFS path for each directory for our application and MySQL, and this is the mount directories. So here it will install the NFS common package, and it will create the mount directories, and next it will mount the NFS shares, and it will verify, and finally it will make the mount persistent. Even the system is rebooted, these mounts will be persistent. So with this shell script, we can able to do all the necessary steps to access our NFS server in our Kubernetes cluster. And next we are coming to next part. We need to create a persistent volume to access this NFS server storage. That means our NFS server is outside Kubernetes cluster, right? To access that, we need a object in our cluster. That object is called persistent volume. We will create a persistent volume with different access modes like read write once, or read write many, or read only many. There are different type of access mode are there. Read write once means here one node, one pod can able to access the storage at a time only, because suppose if we are going to use this persistent volume for our MySQL DB, to maintain data consistency, we must use this read write once access mode for our databases. Usually for the databases they will use this read write once. And second, here persistent volume reclaim policy is retain. There are two types of reclaim policies. One is retain and another one is delete. That means if you use this is the default one. If you use the retain means, let me explain the persistent volume claim first, then only we can able to get the proper understanding. So this is the persistent volume, right? Here one more thing, we need to define the storage capacity what we require for our MySQL DB or whatever. Here we are creating MySQL PV, right? So for that purpose we require 3 GB, and this access mode is read write once, and reclaim policy is retain. Here we need to mention our NFS server IP address. This is the path where we will mount from the cluster node to this NFS server. So okay, and coming to the PVC, here we are going to create MySQL PVC. Actually, what is the PVC? PVC means is persistent volume claim. That means we are raising a request to get access this persistent volume. That means these persistent volumes are created by the Kubernetes administrator manually by mounting the NFS storage. So whenever we are going to deploy our applications in Kubernetes cluster, we need to raise a persistent volume claim as per our requirement. Suppose Here we required 3 GB space for our MySQL DB deployment to persist to use the persistent volume. So with the read write once access mode. So at the time of deployment, first of all we need to raise this persistent volume claim. Based on this volume claim, Kubernetes will search for the suitable persistent volume based on two main informations. One is access mode type and storage. It will match these 2 points. Must be access mode must be same and storage must be less than or equal to the this persistent volume. So using persistent volume claim, it will allocate the right suitable persistent volume for our deployment. So okay, you got the idea about persistent volume claim, right? Now when we are coming back to the persistent volume claim policy, here retains means whenever we have deleted this persistent volume claim, this persistent volume will be retained and the data will be retained without deleting. So that is the use of retained claim policy. If we mention delete means whenever we delete the persistent volume claim, that persisted data in the persistent volume will be deleted. That is the difference. Okay. This is the persistent volume and persistent volume claim for MySQL. In the same manner, we can create persistent volume for our PetClinic app and persistent volume claim also. And before jumping to the next topic, I will explain another 2 type of access modes, read write many and read only many. Mainly whenever we use if you have a scenario where we want to access this storage from the multiple nodes at a time, in that scenario we will going to use this read write many access modes. This is useful for application that require multiple instances to write to the same volume, like file servers and shared logs in multi replica setup like this. This is the use case where you will use the read write many access mode. Read only many means we don't want to write anything, we need to get the static content for our application purpose from the multiple nodes. So at the time we will use the read only many access mode. These are the basic difference between these two. Already we have explained about read write once. That means only one pod or one node can only access at a time that storage. Okay, to maintain the consistency in the data. Okay, here when we are coming to the persistent volume and persistent volume claim for our PetClinic application, here I am requesting 2 GB and read write many here access mode, and claim policy is the retain. When if it is really required a persistent volume for application, means for database it's really required to maintain persistent volume, but coming to the application, whenever we have a requirement to store some logs information and other kind of configuration information which is need to be persisted even after deletion or restarted of application parts, at that time in that scenario we are going to use these persistent volumes and persistent volume claims for our applications also. For testing purpose, here I am going to use the persistent volume for our PetClinic application as well, even though it don't have any data need to be persisted even after getting restarted or deleted. Okay, this is the PVC. Here the same read write many access mode and 2 GB storage capacity. I have raised persistent volume claim for my PetClinic application. So next we are coming to the MySQL deployment ML. Here I am creating the configuration for MySQL deployment. This API version is apps.v1. There is a typo here. Let me correct. I will update further. And kind is deployment. And here we are using the only one replicas because I don't want second replicas. Just for testing purpose, I am using only one replica here. And match labels, all these things you will know. Selectors, we are going to use the MySQL match label. This is the key tag we are going to use in all the parts on. Okay. Here in the template section, we will declare the pod information like is a label. Label is a MySQL, and we are going to create a container using the MySQL 8.4 version. This is the default. This is a default port number for MySQL 3306, and here we are using the necessary environment variables to get access for MySQL DB. And here this is the volumes where we are going to create persistent volume claim. So claim name is MySQL PVC, and MySQL persistent storage is the volume name, and this is the volume mounts where we are going to mount is our PV using PVC. This /var/lib/MySQL is the default mount path for MySQL database. And after that we are going to create this service for this MySQL DB. Here we are selecting the type as cluster IP because I don't want to access I don't want to get access for my SQL DB outside the cluster. So that is the just we need to maintain the internal communication. So for that purpose I have selected cluster type, cluster IP type. This is the port and the target port number. So when coming to the PetClinic deployments, in the same way, here we are maintaining 2 replicas for our application, and remaining things same as like MySQL DB deployment what I have explained earlier. Here containers we are going to use the image PetClinic Spring App version. This it will get from my Docker Hub. So this is the content port is 8080. Here I am going to use the necessary environment variables to get connectivity between the application and database, like MySQL URL, username, password, root password, and database, all these things. And coming to the volumes, here I am going to create create 2 types of volumes. One is empty directory volume and another one is persistent volume claim. Just because of testing purpose only, this empty directory volume, as I said earlier, is if you don't have any data which is not to be persisted even after the parts get deleted and restarted, for that purpose like caching and any temporary files, for that purpose only we have to use empty directory. Actual usage of empty directory volume is whenever our pod has 2 containers, like one application container and another sidecar container, which need to be shared the resources and need to share some temporary files information, all those things. At that time we will create this empty directory volume. That is the purpose of empty directory volume, but it is not persistent. These non-persist type volumes in the Kubernetes. So for our application we are using 2 volume types, and these are the volume mounts, 2 mount paths. For empty directory is /temp/cache, and for our persistent volume /app/data. Based on development team configuration, if is there any such kind of information need to be persisted, they design at the time of development, then only that data will be stored in this mount path. Okay, and we will create one service like PetClinic service for with the type node port, because we want to access our application outside the cluster, right, using our node IP and this port node port. So for that purpose we need to create this service to maintain the communication between the deployments. Okay, so everything is clear. Now we'll go to here you can see I have set up NFS server first. Just I'm trying to show these images. Successfully my NFS server has been configured, and I have integrated with my Kubernetes cluster nodes in the master node and worker node 1 and worker node 2. Successfully I have mounted all these NFS volumes. So what I did in this project, first of all I have used this deployment. I did the deployments without any persistent volumes, like with only empty directory volumes for testing purpose. Here you can able to see here just I have used the empty directory volumes deployment. So we can see here temp.cache, there is nothing there. I have created some files information, and whenever we delete the pod, we are unable to access that information. That is the concept of empty directory, right? Even when we are browsing, when we are accessing our application on the browser also, even though we have added some new owner's information, whenever our application pod or our database pod gets deleted, we can't able to get the information. Okay, here you can see is the MySQL DB. I'm getting into the MySQL DB pod. So to get the information from the tables using root user. Here these are the databases. This is our database PetClinic, and these are the tables in our PetClinic database. This is the information from owners table and pets. Here we have added one user rights and the pet under this owner. Okay, now here I have deleted the MySQL DB pod, and you can see we are unable to get the information about the owners. So whenever we have deleted, that information has been lost. So here also you can see once we delete the MySQL DB pod, and after that once we log into the database, we can able to see only default users. That newly added users information is gone. Okay, that pet details also gone after deleting the MySQL DB pod. This is the why we require persistent volumes for our database. So to address this issue, we are going to use NFS volumes, and we'll observe the difference. For that purpose, already I have explained about PVC, MySQL PV, PVC, and all these things, right? I am using those YAMLs to create those objects. Here I have created MySQL PV, and further I have created MySQL PV request, PV claim, and I have deployed MySQL deployment. And here you can see both MySQL pod is running, the service is running, and deployment is running with the one replica set. Okay, and at the same time I am going to do the same with the PetClinic application. Here first of all I am going to create the PetClinic persistent volume and persistent volume claim. At the same time I am going to deploy my PetClinic deployment. Here you can see we can successfully able to run these parts. Two parts are there for our PetClinic application, because we have mentioned two replicas, right, in our deployment YAML file. So this is the PetClinic service with that node port type. This is the IP, and this is the port number, and the deployment also you can able to see the PetClinic app with two replicas is ready. Okay, this is the replica set with two replicas. So now I have able to access my application, the default data first, and you can check in the backend also. This is the using kubectl exec, we can able to get into the MySQL DB part, and we can see you can list what are the directories are there, everything you can see. This is the mount path what we have created in our volumes, right? /var/lib/mysql. You can able to see all the information which is stored when we are accessing the application. So, and I'm logging to the MySQL cell using root. So here you can able to see the database tables in our database, and all these things already I have explained, right? Now we are going to add new owners with the pets in our application in the browser. So here I have added 2 new owners along with 2 pets information. You can see that that new owners information in the backend also it has been reflected. Subba Reddy and Ramesh, these are the new owners, and Simba and Puppy, those are the new pets under these new owners. So this information has been updated in the backend. Now I am going to delete the MySQL part. Here I have deleted the MySQL part, and you can see it is deleted, and it has been created a new part and is running successfully. So, and here also here I have deleted PetClinic application part, and here I have deleted the MySQL DB part. Both are now created new parts and running. Then we are going back to our application in the browser. Still we are able to get the information about the new entries in the database. See, this Subba Reddy and Ramesh Kamla, both information is persisted even though we have deleted the parts like application part and the MySQL DB part. So our NFS volume is working perfectly. So now you can check it in the backend also by logging to the MySQL DB part using the same process. Here you can able to see the both owners information and both pets information is persisted even after we have deleted the MySQL DB part and as well as PetClinic application parts. So that's the main usage of NFS volume, that is the persistent volumes type, and you can check it in the NFS server itself. You can what is the mount directories what we have created in the NFS server. So here in this picture you can able to see these the 2 directories we have created, right, when we are configuring the NFS server. So MySQL and PetClinic. In the MySQL directory you can able to see these are the information already stored in, it is reflected in this is a PetClinic directory is there. In that PetClinic directory you can able to see this owners.ibd, pets.ibd, specialty. All this information has been stored in this NFS server. So coming to this PetClinic directory, mount directory, there is nothing in the directory because for this application they might not be configured any this persistent information. So that's why there is no data has been stored like any application logs information. All these things not stored in this mounted directory. Okay, got it? Okay, this is the final conclusion for our NFS volumes project. So all the steps I will explain once again. We need to set up an NFS server, we need to create volume configurations like persistent volume and persistent volume kinds for our MySQL DB and at the same time for our PetClinic application if you required. Otherwise you can ignore for PetClinic application, you can use it only for MySQL DB. Okay, and here we have to create the volume claim to backed by the NFS server to the data stored in the default mounting directory. So even though we have deleted the parts, the data will be stored in the NFS server under this directory, mount directory, like already I have shown in the previous image, right? So when coming to the persistent application, we have used empty directory volume and persistent volume claim also, but there is does not generate any information, because that this application might not be configured such kind of persistent data. So that is the thing. So this is the project, guys. I have created for testing purpose, to explain you everything I have recorded in this blog. You can able to do your own by following all these steps. By using shell script, you can able to set up an NFS server, and you can able to configure with your cluster nodes, and all the PV and PVCs deployment YAML files I have shared in this blog itself. So you can try this, or you can try to implement this to get confidence by using of NFS volumes in Kubernetes. Okay, thank you very much.